Space, the final frontier. This is the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. Its mission to explore the solar system, to seek out new observations and data, to boldly go where no podcast has gone before. And now the host of the Observer's Notebook, Tim Robertson.
Hello and welcome to episode 153 of the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. I'm Tim Robertson, the host of the Observer's Notebook and also the coordinator of the training program with the ALPO. Thank you for downloading and listening. The Association of Lunar and Planetary Observers collects and analyzes observations of various solar system bodies and associated phenomenon, and publishes detailed reports concerning these bodies in its quarterly publication, the Journal of the Association of Lunar and Planetary Observers. This podcast depends upon donations from you, our listeners, to keep it alive. If you enjoy what you hear on the podcast, you can donate to it via Patreon. You can start off by giving as little as $1 a month. If you feel even more generous, for $5, you receive early access to the podcast before it goes public. For a monthly donation of $10, you receive a copy of the Novice Observer's Handbook. And for $35 a month, you receive producer credits on the podcast. You can help us out by going to www.patreon.com/observersnotebook. And if you'd like to join the ALPO, you can for as little as $18 a year. For more information, join us at www.alpo-astronomy.org. And you can also find the ALPO on Facebook. Just search for ALPO Astronomy. And also this podcast also has a Facebook page. Just search for Observer's Notebook. And if you enjoy what you hear on the podcast, please subscribe. That way you'll never miss another episode. And now, episode 153 of the Observer's Notebook, and we're talking Mars. Enjoy. All right, I'd like to welcome everybody back to this edition of the Observer's Notebook podcast. And we're talking Mars, and that means we're talking Roger Venable. Welcome back, Roger.
Thank you.
Now, before we get into it, why don't you talk a little bit about yourself, where you're located? You're retired now, maybe talk about that type of thing. So everybody gets to know who you are.
Yeah, well, I'm old, and I started observing Mars when I was probably in about 6th grade, 7th grade, with a small refractor. And then we had a small reflector, a 4-inch criterion reflector that we looked at it with and so on. We could see some basic albedo features, but mostly I've been a general solar system observer. Hadn't concentrated on Mars too much, but I wrote some articles about Mars for the journal years ago, and I think that Don Parker and Walter Haas sort of remembered that and remembered the drawings of Mars that I had fortunately published in Sky and Telescope, and they kind of asked me to be Mars coordinator. So that's how it happened, and I said, I can't turn you guys down.
I hear you. Yeah, Walter had a way of getting what he wanted.
Yeah, right.
It's just, was there a person or some event that originally sparked your interest in astronomy?
Actually, there was, and it's really, I don't know how many other people have a similar experience, but when I was 6 years old, my father taught science in high school.
Oh,
and he brought home a refractor, and it I don't really know about the refractor, but it looked, like the Unitron refractors that were advertised back in the 1960s.
Mm-hmm.
And it probably had about a 3-inch aperture, and didn't have a clock drive or anything. It was like altazimuth mounting. He set up in our backyard, and he showed us the moon, which was a crescent moon, a thick crescent moon. And to me, I had never seen anything through a telescope, and my brothers and sisters, older than I, thought it was quite interesting. And I looked at it, and the mounting would not hold still. And I looked through it. My father warned me that I wouldn't be able to see anything because it was no longer pointed at the moon. And I tried to point it, and I swept slowly through the area of the moon, and I saw it, but at age 6, I couldn't hold it in the field of view, but I probably saw it for 1 second as it moved across the field of view, and I saw all these craters and shadows and things, and it was an immensely eye-opening experience for me to realize that there is so much more to see than what you can see with your naked eye. I mean, it was amazing to me, and since then I always wanted to see more through a telescope. And to this day, I think the moon is the best initial subject matter to show to a kid who wants to look through a telescope.
That's true, because it's easy to see, and you go to an outreach event, and everyone wants to see the moon through a telescope, and just the drop moment, that most people have the first time they look through a telescope, it's rewarding. But that you're describing the exact same feeling I had, the first time I looked through a telescope too. And I think everybody listening, first time they look through a telescope, same thing. That's very cool. Now, was that refractor your first telescope?
Actually, that belonged to the school.
Oh, okay.
I'm not sure why Dad brought it home, but he brought it home several times. I only got to look through it once. I think he was trying to discover whether he could use it in his science classes, or something. But after a PTA meeting, kids like to get out in the dark and look through a telescope, and sometimes things like that happen. But I don't think he ever learned the night sky at all, and was never really able to use the telescope except to look at the moon. So.
Yeah, that's great. How did you get involved with the ALPO? You mentioned Walter, but how about before that? I mean, how did you discover the ALPO?
I had some small telescopes when I was young, and I'd seen the Messier objects, and I used the Norton's Star Atlas and so on as a guide to the sky. And I remember I used Compton's Pictured Encyclopedia to learn the constellations, and I read some books in the library, and I remember there was a shelf of books on astronomy, and sometime when I was in high school, I read them all in the library. I was really fascinated with deep sky observing for years, and probably spent most of my time on that. I had a couple of Meade DS-16As, which had a clock drive, 16-inch telescopes.
Oh, wow.
Parties observed in my backyard and so on. And I actually did some rudimentary video through the DS-16A. I videotaped a couple occultations with a huge video camera that recorded on tape instead of the way we do now.
Right. And
this thing had to be strapped onto the large telescope tube, and I had to use a mirror to reflect the light, an additional mirror to reflect the light, and a Barlow lens, and I had to laboriously focus or something. I don't remember all the details, but it was not easy to use this thing.
Right. It doesn't sound like it. No. The old videotape. My goodness. So, how long have you been in the ALPO?
Oh, I joined in 1987.
Okay.
I considered it for years, but I was just very busy. I just really didn't have any time except to read sky telescope. That was, and then do occasional observing through a telescope. I just didn't have time for ALPO programs and so on. So it took me a while to make room for that.
Okay. But since the 80s, you've seen quite the evolution of the organization too, haven't you?
Yeah.
So what are some of the highlights you think you've seen over the years?
Oh, well, gee, now I wish I had more time to think of them. Certainly, some of the best things I've seen are eclipses, especially solar eclipses. And I've really enjoyed going to a few of those. One of the great highlights was seeing the scars on Jupiter from Shoemaker leaving 9.
Yeah, definitely.
And I was watching the night of the impacts and watching them develop and move across the face of Jupiter. And I wasn't able to see a flash when fragment B hit. Fragment B was very small some people actually hypothesized that it was mostly gas instead of a solid core of the comet. But it left a mark, a faint mark that didn't last long. And but that was really an exciting time for me, just to see that. Used to count meteors with my naked eye, and for a long time I reported them to the International Meteor Organization. And my vision became too bad to continue that. I just wasn't able to focus on a very wide field of view. I pointed a telescope at the moon at the peak of the Perseid meteor shower. I think it was 1990. Let's see. No, it was the Leonids in 1999, and I recorded one flash. I think I'm going to get this wrong. It's hard to remember all these things. I think maybe I recorded the flash the next year. But I decided that there was too much glare from the moon to record the dark side of the moon. So I began to observe visually. And I estimated that I was seeing one flash on the moon through my 16-inch telescope about every 15 seconds on the average.
Wow.
And so I believe that I saw many Leonid flashes on the moon. And this is the same shower for which David Dunham and Brian Kudnick videotaped meteor flashes on the moon.
Okay, all right.
And I claimed to have actually seen visually many. And I wrote a letter to the WGN, which is the journal of the International Meteor Organization, describing my experience. And they published the letter, but my observation, I think, has been forgotten.
Well, that's interesting. I didn't know that.
You really get excited when you see things like that.
Oh, I bet. Yeah. You mentioned Shoemaker Levy, and I remember that time, and no one really thought we'd see anything, but I remember seeing Jupiter rotate around. There's a black dot, and then another black dot, and another. Right. I'm like, oh my goodness. Yeah, it's amazing. That's pretty cool. We're talking to each other just a few days after the DART spacecraft slammed into the asteroid, and the images that are coming back now, the Earth-based images, are amazing.
Yeah.
It's just like a huge cloud formed around this asteroid, the moon of an asteroid.
It's just amazing.
It is. It's things you don't expect to see. And now the science gets thrown up in the air. Now let's figure this out.
We did some interesting things at my observatory. One night, I had planned this carefully with the 16-inch telescope. We planned for a night when Pluto would be both at maximum elevation in our sky, because Pluto was in the southern sky, and Charon, according to the horizon's ephemeris, would be at maximal elongation from Pluto. And we got up there at about 460 magnifications, and we saw Charon.
Wow. And
there were 5 of us there. I can probably name them. One of them is now my wife. That's and John White, and let's see, Mark Moffat, and Jerome Leverett. And those were the 5 of us who saw it. And we all saw it, And then we also could see it at double that, about 920 magnifications. I'm not sure that improved the view. And alone, I came back a few other times and also saw it again. So I've seen Charon several times.
That's impressive. I think I've seen Pluto once.
I don't want anyone to say ever that I've told Charon that we have to stop meeting like this. My wife will hear that and not understand that it's a joke. We have to be sure that I never say that.
That's funny. That's funny. So how did you get into Mars as a coordinator of the program? What was it about?
Well, I don't think I had a real special interest in Mars at the time. It was one of the things that I enjoyed observing. As I said, I'd made some drawings of it and so on, and I paid attention to its features.
Right.
I had never seen a dust storm on Mars at the time they asked me to to be coordinator. I had written about Phobos and its eventual crashing into Mars in the article in the ALPO journal. And I don't know if I had any other Mars. Oh, I had witnessed with the 16-inch telescope Phobos and Deimos on the same night. Saw Phobos on each side of the planet and Deimos on one side of the planet in that night of observing. So I've seen those two moons a number of times since. So I think because they knew that I had done these things, they just thought, and they had seen a few other things that I'd written for the journal. They figured I was probably capable of doing it or something.
Fantastic.
They may not have been correct, but they thought so.
Well, you've done it for a while. You're doing a great job. So that's excellent. Now you talked about the 16-inch telescope. Is that your current equipment?
I have two 16-inch mirrors, neither of which are being used.
Okay.
So right now I mostly observe occultations. And I happen to have an additional astronomical responsibility. I'm vice president of the International Occultation Timing Association.
Okay.
But one of the most exciting things that I've done, what happens is you have a moment of great excitement when you see something happen. We had chased the near-Earth asteroid Apophis around the country, setting up in various places in the country, trying to observe occultations by it. And the Dunhams, in a group of people, a campaign of many people lined up across the path trying to record an occultation. The Dunhams recorded 2 chords, and Richard Nugent recorded 1 chord down in Louisiana in early 2021. And in follow-up, we tried to get some observations, and we had misses in Japan and misses in Greece, and we wondered why, if we knew where it was from the previous occultations, which measured extremely accurately, how come we had misses? And so we had a couple more campaigns in the United States, and I got 1 hit way over on the extreme of all our chords that we had set up. Mm-hmm. And that gave us a clue that the observation in Louisiana was misleading because the star position was not well known. It turned out to be a double star.
Oh.
So we said, well, we got to try to verify this. And I drove out to Arizona and set up 5 stations. And with me was Norm Carlson and Kai Gatrost, and each of them set up 1 station. And I put them in the middle, and I hit the flanks, and each of them got a hit, and I had a hit next to them. We got 3 hits across Apophis. Now you have to understand, Apophis is something like 340 meters in diameter, not kilometers, meters. Wow. It's a third of a kilometer in diameter. And so we have been able to accurize the orbit of this asteroid with phenomenal accuracy. In fact, accurize it sufficiently that now the Yarkovsky effect in the orbit of the asteroid has been more accurately calculated than that for any other asteroid, surpassing Bennu by a small amount. So,
wow,
this is the gives you an idea of the accuracy to which occultation measurements can locate the position of an asteroid.
Interesting. Now, for those newer listeners or younger listeners that don't know what an occultation is, it's when one heavenly body passes in front of another. And yes. So when an asteroid passes in front of a star, the star seems to blink out because the asteroid's probably a lot dimmer than the star you're observing. So it actually disappears, and it will disappear for a second or two, and then pop right back in. So, and that's the type of observation that Roger's talking about. That's amazing.
Yeah. The thing about that particular observation was that we had been chasing this asteroid for the better part of a year. And when we finally got the final convincing hit that nailed down the orbit, this is the kind of thing that makes an old man jump up and down.
I hear you. Yeah. Yeah, and this is science that our amateur astronomers are doing, which is one thing I love about this hobby. that you don't need a professional. I mean, the professionals use the data that you give them. You know, they're not out there tracking these occultations of asteroids. It's amateurs that are doing it, and that's amazing.
Yeah.
That's great to have a contribution to science that way. And we're going to talk about an occultation later, but first, let's talk about Mars.
All right.
Mars is going to reach opposition to the Earth on December 8th, I believe, right?
That's correct.
Okay. So let's talk about the Mars section a little bit. Talk about what its goals are and how long it's been around, that type of thing.
Right now, I think we have somewhere in the neighborhood of 1,100 people in the Mars observers list. That many of them are contributing observations, and I think they're on the message list just so they hear what other people are doing and get notified of other people's observations and so on. And most of them are lurkers. You know, that's fine. You have to respect every lurker. At least they're expressing interest by being there. You know what I mean? And so, you know, it's really an active group, and there are a lot of observations being done, many hundreds of observations already in this apparition, which began, I guess, around the turn of the year. So it's right now, Mars is roughly 11 arc seconds in apparent subtended diameter, and that's a sort of an intermediate size. You know, small is smaller than 6 arc seconds, large maybe larger than 15 or 16 or something. We're at about 11. Okay. And as Earth is catching up to Mars in its orbit, and so Mars is getting closer and closer as Earth overtakes it as they go around the sun together. And so the opposition is when the Earth moves into a position between the sun and Mars. And that just happens to be on a night of a full moon in December 8th. Mm-hmm. And it happens that, you know, the moon that night is going to move in front of Mars, and from northwestern Europe, probably extending from northern Germany, including the Scandinavian countries, the United Kingdom, France, and the Iberian Peninsula, and even Morocco, as well as most of North America, but excluding the southeast where I live, will be able to see this the moon pass in front of Mars. This is usually a fascinating thing to observe, and it's particularly good if you can get on the line where it just grazes the edge of the moon. That is, the moon is moving faster than Mars in the sky, and the moon, as it moves past Mars, doesn't completely occult it, but rather may occult, say, half of the planet. So just the edge of the moon seems to be floating past the planet. There are a couple of interesting things you can see with that. You can actually discern mountains on the edge of the moon in profile as they obstruct parts of Mars beyond. And in this particular case, if you're on the southern edge of the path, this is a little difficult to explain, but there should be a very thin black line of the moon which is not illuminated by the sun. The reason for this is that if you drew a line directly between Mars and the sun, the Earth is slightly south of that line. Now, it's south by 2.5 degrees or so. Now, what that means is that as you look at the moon, the lower 2.5 degrees of the moon is not illuminated by the sun. Wow. It'll look black, and you can't see it because it's not illuminated. So ordinarily, if you shine a telescope at the moon, you can't see that unilluminated part. But we call it the illumination defect. But if Mars is being grazed by the moon, there'll be a thin black line, that 2.5% of the moon's circumference, actually 2.5 degrees of the moon's circumference, that thin black line between the body of Mars and the illuminated part of the moon. And it's just something interesting to see. And if you understand what's going on with it, it really makes a very impressive geometric impression. You see what I mean?
Like it. Now, are you going to shoot to be in that that area to see?
I would like to see this. I mean, it'd be nice to travel up to Tennessee where I can get a look at it,
Mm-hmm.
But I don't think that such an observation has scientific value, but it's just so fascinating to see that you just want to enjoy it,
I was not aware of that. That's interesting. Wow. Now, what if someone, let's talk about the Mars section for a little bit. If someone wants to contribute to the Mars section, what type of equipment would you recommend?
Well, Mars tends to be a little small in the eyepiece, and I really think that most observers should try to get a 6-inch telescope, 6-inch or larger, because a 4-inch telescope just doesn't quite seem to do it. I mean, you can see the orange or ochre deserts and the greenish or bluish, what they used to think were seas. The dark areas on Mars tend to have a greenish or bluish tinge, perhaps largely in contrast with the orange. If you're standing next to something bright orange, why everything looks blue or green in contrast. So that's part of how Mars's colors are generated, I think, generated in the human brain. But you see that with a 4-inch telescope, but you just don't see it as clearly. You really see a lot of improvement when you move up to 6 inches. So I usually recommend people try to find a 6-inch telescope to view Mars with. And and Mars requires fairly high magnification because it's so small.
Right.
And nowadays, a lot of observers have turned their big, deep sky imaging telescopes on Mars and so on. We see a lot of general imagers who are taking pride in the very fine images of Mars that they can make. So we appreciate that. Right now, we're having a dust storm on Mars, and it's being imaged by Japanese observers. The dust storm obscures the normal features of Mars. So when the atmosphere is full of dust, all you see is the bright dust, and you can't see the surface of Mars beneath it. And the dust clouds can have a variable brightness, so you see false albedo features, such that the dark areas look like dark spots on Mars, but they're just less brightly reflecting areas in the dust cloud. So it's kind of interesting to follow a dust storm from night to night, or even from week to week if it's a long-lasting one. But you can't see it from North America right now or from Europe. And the reason is that Mars rotates on its axis roughly 24 hours and 40 minutes. Mm-hmm. That's about 40 minutes different from the Earth's 24-hour rotation. Well, that means that when the two are rotating, we see almost the same side of Mars every night, you see, but we're only off by 40 minutes. Mars is 40 minutes behind us. Well, Japan right now is seeing almost the same side of Mars every night, and it happens to be the side that's having the big dust storm.
Okay, so it's not a global dust storm like we've seen in the past. Okay.
We call it a regional dust storm.
Okay.
And it's affecting the Solus Lacus area, Mare Erythraeum, and Mare Acidalium, and Chryse, and Aurora Sinus, and Margarifera Sinus. And we're waiting for it to spread into Tharsis, and perhaps in the other direction toward, into the Sinus Meridiani and Edom and those areas, and Noachus. So, but we'll just have to wait and see if it spreads. Sometimes it just calms down. It looks to me as though the first image of this storm was actually captured as a North Polar front spreading from the North Polar front up into the temperate latitudes on about the 14th of September by Gary Walker, who's here in Georgia. And then we sort of lost track of it as that part of Mars with its 40-second delay, 40-minute delay every rotation, it gradually became invisible to us here, but it became visible eventually to the folks in Japan, and they have now been documenting a larger dust storm, and it seems to be in the same area. So it's going to be fascinating to see whether that spreads or whether it's still visible when that part of Mars rolls around into our view.
That's fascinating. But the side we're seeing has no dust storms, so the features are easier to see at this point, even though Mars is a little bit smaller. Okay. Now, how large is Mars going to be at opposition?
I've got that data. Pardon my poor memory. It's going to be about 17.2 arc seconds in subtended diameter.
Okay.
Closest approach is a week before opposition. That sounds a little strange. You say, well, you mean it's not closest when it's directly opposite the sun? It's not. And the reason is that Mars' orbit is relatively elliptical compared to Earth's round orbit. So as Mars will, at opposition, just be on that part of its orbit where it's getting farther from the sun. So the Earth will catch up with it in its orbit, but Mars will be farther from us at opposition than it was a week earlier, you see.
Okay. Yeah, I like these podcasts with the planetary coordinators around opposition, because that's when the planet is its largest, and most people don't want to get up at 2 or 3 in the morning to pull their telescopes out, but this is when they become visible in the evening sky. But Mars observations, like you mentioned, you've been receiving them since January, probably.
Sure. Yeah. About them. So.
Yeah. So what did you see in the last apparition of Mars that's new or different or interesting this year?
In the last apparition, we had a number of recurring dust storms that came from the south polar front. And Clyde Foster, for example, documented one after another. And these are analogous to the storms that we get when the jet stream comes down over North America. That jet stream is actually the North Polar Front. And but it swings down into the temperate latitude, and there's also a South Polar Front that swings northward into the temperate latitudes and so on. And Mars has these same effects with its polar fronts. So we just observe these storms. Some of the storms are limited to the polar areas, and we call them polar cyclones, and some of them break off from the polar fronts and move into the temperate latitudes with cloudy areas and so on, and these can sometimes start dust storms because of the strength of the winds. But these are in the temperate latitudes. We refer to them as just as cyclones, temperate latitude cyclones that originate from the North Polar Front. But as you recall, if you listen to the Weather Channel, when the jet stream is sweeping down over North America, storms happen. Air masses are on the move, and they interact at their edges with great storms. And that's what we see on Mars in addition. So a dust storm can happen anytime on Mars, and any time of the year. The really big ones tend to start in late spring or early summer. But they too can start at odd times. And the last big one we had, it's embarrassing not to remember this exactly, but it started, as I think, in an unusual season, couple of apparitions ago. Very unusual season, and it was a planet encircling dust storm, obscured the entire planet. So.
I think I remember that. Yeah. But from what I remember, a lot of these are seasonal, though. Mars has seasons just like the Earth, but yeah, because the weather pattern, the polar caps tend to grow and shrink, that type of thing as well.
Yeah.
Okay. So you mentioned the dust storm that's currently on Mars. What other things are happening on Mars that observers, if they start looking now, should be looking for?
Well, goodness. The problem with this is that with the question is that there are frequently clouds on Mars, and we like to document them, and in long term we like to document where they occur and how often. So there, you may get lucky and see a cloud.
Okay.
There has been a peculiar cloud on Mars, located in just south of the equator, halfway between Syrtis Major and Tyrrhenium Mare. And this started as a cloud, and after a while, it just became a white spot, and it was bright in red, green, and blue, which is inconsistent with a cloud. Clouds are usually definitely brightest in blue. Dust storms are brightest in red. So this is very peculiar, and we've had a difference of opinion about what this cloud is.
Okay.
Does it represent snow? For example, it could have been that there was a heavy storm there and it snowed on the surface, and that's why this white spot lingered for a week, and it's gone now. I've previously wrote about the 2007-2008 apparition that I had a couple of cases that it snowed on Mars. A big storm passed and left behind a light surface that features of which were inconsistent with dust or cloud, and it was probably on the surface, and it was left behind by a storm, and that suggests snow. And the snow is likely to be water ice, not carbon dioxide. So, but these things do happen, and it may have happened again in early September.
Interesting. Now, you mentioned looking at Mars through different colors. You're talking about color filters, that type of thing. And because I know when I look at planets, I always use color filters because depending on the ones you use brings out different details, like you mentioned.
Right.
So what color filters bring out, like you mentioned, the red and the blue filters? What other filters can we use to look at Mars?
Let me say firstly that if you're observing visually, the color filters need not be expensive. But if you're observing with an imaging camera, the color filters are expensive because they're hard to make. The imaging cameras are more demanding of your filters. The old Ratten filters are fine for visual observing. And in looking at Mars, if you use a red filter, it really makes the contrast stand out because it lets all the red of the deserts in, looking bright. And the blue or green areas don't have as much red light reflected, so they look darker. And so the contrast on the surface of Mars is greatly increased by a red filter.
Okay.
A blue filter, if you get a strong blue filter, like the W47, which is what I recommend, is the W47. W stands for Ratten. Old filter that Kodak bought out the Ratten company back in the early 1900s and continued to use the Ratten name on their filters. But the Ratten 47 filter, or W47, I think of as a violet filter.
Yeah.
And it makes clouds bright and the rest of Mars dark. And ordinarily through it, you can usually see virtually none of the albedo features of Mars. That is, the surface features. You can't see them because all that light is scattered by the atmosphere. And the violet filter will show what's in the atmosphere, and clouds reflect brightly. So you see clouds best. If you're looking for clouds, look for them with a violet filter.
Okay. Yeah, that violet filter is pretty dark. I use that when I do Venus observations because it just cuts down that light, and that's when you can start to see the cloud details again in Venus.
I've also used it for Venus, and I really think that sometimes you can see details in the clouds with the W47 filter on Venus that you can't see with other filters. So it's worthwhile.
I agree with that. Yeah. So you talked about imaging. The types of observations you're looking for. So you'd like images, and what about visual observations as well?
Well, there are a number of good artists who, Carlos Hernandez is famous for his wonderful drawings of Mars, and there are a number of others. We've gotten, right now, let me just tell you that Abel, I'm sorry, I'm having trouble. Paul Abel in England is making wonderful colored drawings of Mars, and he gives good descriptions of what he's drawn and so on. I've been getting regular drawings from a Mr. Korn in Germany, and Michael Rosalina is a good Mars artist, and there are just a number of others. So, but I just think that drawings are always useful, particularly if there's something going on Mars. For example, if you have clouds, it's very helpful to know what they look like as seen by a Mars artist, in addition to what they're like with images. And that gives us, in fact, a sense of correspondence with classical observers of the past who never could image Mars, but always drew it.
That's good. It's a good point of reference, too. Yeah.
Yeah.
Very good. Very good. So it's coming up on opposition in a couple months. Are your observations that you're receiving increasing?
Yes. Yeah, we're getting a lot of them now. In fact, I probably got about 8 or 10 of them today, and I've been busy, haven't had time to download them.
Okay. All right. Now, for visual observers, you have observing forums online that people can download?
Yeah, if you go to the ALPO website, you'll find in one of the columns on the face page, the Mars section, and if you go there and you'll find another column of things to click on, and among them is the report form for people who wish to make drawings. And let me say one other thing. We like to see if people can perceive something called blue clearing. That is, with the violet filter, or the W47 filter, observing visually as they look at Mars, can they detect albedo features? Now, this sounds like a peculiar question because I just stated that you can't see albedo features through the W47 filter. But every now and then you can. And there are some theories about this. And what we want, and the problem is that let me say firstly that the most prominent theory is that it doesn't exist. There's no such thing as blue clearing. And blue clearing being the times when you can see albedo features through the violet filter. We say that blue clearing is occurring. And we like to see people try to document that and report if they detect some degree of albedo features. And we like people to rate it on their own scale because everyone's perception is different. We like to say there's 0 blue clearing, or it's a 1, 2, or 3. That's kind of what we do in a subjective way. And long term, we wish to coordinate all these things in an article, and we'll see if it is associated with things like the declination of the sun or the earth in the Martian sky, and the elongation of the sun, of Mars from the sun in the sky. That is the closeness to opposition, things like that. We just want to see if it has any associations with physical parameters of Mars that have not yet been proven.
Okay. Now, by albedo features, you mean like surface details?
That's correct.
Okay. All right. Because normally you would just notice the clouds with the violet filter, right?
That's right.
Okay. Okay. Very cool. All right. I will do that when I get my telescope out and look at Mars this year. I hadn't thought of that. Well, is there anything else you want to share about yourself or the Mars section?
Well, let me think. I think that pretty much covers it. The problem with Mars is that it's overwhelming. I mean, if I were to, I wrote, one apparition report of Mars, and it was 52 pages long. It's the longest article ever published in the JALPO. It's as though, I know that nobody read it because it's too long, and so they're completely unfamiliar with all the phenomena I described.
So you're the reason the journal's now 100 pages long. Okay. Hasn't Ken talked to you about that?
Well, he said, if you write another one, make it shorter.
That sounds like Ken right there. Yeah. Yeah. Well, Roger, this has been great and amazing and wonderful, and I wish you a lot of luck with your Mars section this year. I think it's going to be very dynamic, and hopefully we don't have a global dust storm on Mars where we get clouded out on seeing anything.
Okay. Yeah. That can sort of ruin the apparition, that nobody can see any albedo features because the dust is in the way.
That's right. And I'll put links in the show notes to your email address if people want to get a hold of you, and also links to the Mars section of the ALPO as well.
Yeah.
All right. Okay. Sounds good. Well, thanks for chatting with me today.
It was my pleasure, Tim. Good to see you.
Well, that'll do it for this episode of the Observer's Notebook podcast. I again want to thank Roger Venable for coming on and talking to us about Mars in 2022. We upload a new episode of the Observer's Notebook on the 1st and 15th of every month. You can subscribe to us on iTunes. If you do, please rate and review us. I really appreciate it. And you can also listen to us on Apple Radio, iHeartRadio, Soundcloud, Spreaker, Google Play, Stitcher, Amazon Echo, Spotify, and yes, we're also on our YouTube channel. You can help support the podcast by donating to it via Patreon by giving up to $35 a month, where you receive 1 year's membership to the ALPO and producer credits. And with that, I'd like to thank the producers of this podcast, Steve Siedentop and Michael Moyer, for their continued generous support. Thank you very much. The link for Patreon, the link for the ALPO, is in the show notes. If you'd like to get a hold of me, you can email me at commentman@commentman.net or on Twitter at @observersnbpod. And until next time, I hope you always have clear and steady skies. Thanks for listening.